Hello guys, so on our series of studying statistics, so today I wanted us to tackle some questions on distributions and conditional probability. So with me I have two questions on the screen. The first one is saying consider a random variable x with a discrete uniform distributions on the integers numbers 20, 21 to 79. Then you can see clearly that our Roman one says that we determine the expected value of x. So definitely here you need to get the mean of our discrete uniform distributions. Then the Roman 2 says that you determine the standard deviation of x, which means that we will definitely have to get the variance of our discrete uniform distributions for us to be in a position to get uh, the standard deviation. Then question 2 says that an analyst has modeled the loss in units of 1000 due to a fire in a supermarket using a random variable x. So with the density function of the form that we have on the screen, a into bracket x minus 20, for the value of x lies between 0 and 20. So that is the limit of x, where a is a real number, so that is it. So the first question says that you determine the value of a. So we'll have to determine that. Then Roman 2 says you calculate the conditional probability that the fire loss exceeds 16,000 given that it has already exceeded 8,000. So we'll start with our question 1. You don't consider random variable x with a discrete uniform distribution. Determine the expected value of x, and then you determine the standard deviation of x. So from the first question that you've seen, we told that we are given, so we are trying to solve the question. So you see, the first question was we were given a discrete, we are being given a discrete uniform distribution, Please make sure to check out my other videos on this. We have discrete distributions and continuous distribution. So in this case, we have already been given. So and then we're being told we are being given a random variable x, variable x, yeah, up to xn. Yeah. So then you're being told that it has numbers 20. It has 20, 21 to 79. Yeah. To 70 to 79. So that is our numbers. So the first question is that you're being told to get the expected value of x. We get the expected value of x. So the solution here, what you need to know very well is as far as that is concerned, you know that if you're trying to get the expectation is the same as getting the mean. So insert your equation editor using shortcut alt is equals plus. So you can write the mu. Mu is the same as the expected value of x that we are trying to get. And remember that this is a uniform, discrete uniform distribution. So you'll have to, since it is a uniform distribution, so it will be a plus b, a plus b divided by 2. So notice that from our random variable x, definitely our value of a is equals to 20, and our value of b is equals to our value of b is equals to 79. Our value of b is equals to 79. So it means that by us doing that, so we put backslash of mu is equals to into bracket of 20 plus 79. So 20 plus 79 divided by 2. So in short, this one is equals to 99. So 99 divided by 2. 99 divided by 2, you get 49.5. Calculate 99 divided by 2. So you get 49.50. So you can insert our equation, and then we say therefore our mean expected value of x is 49.50. So that is your answer. When we go to Roman 2, So Roman 2 was telling us to get the standard deviation. So here we get the standard deviation of x. So definitely we can come here and just write our solution. So it means that for us to be able to get the standard deviation, so we can insert our equation editor. So from our statistics, we know that very well. For you to be able to get the standard deviation, so this is just is equals to the backslash of our SQRT. SQRT means that is the square root of our variance of x. Variance of x. So that is it. Yeah. So we insert our equation editor whereby our variance is given by our variance of x is equals to, which can also be written as var of x. So this one is equal to our value of k squared, k raised to power 2 minus k raised to power 2 minus 1 uh, divided by 12. I know most of you are wondering where the k is coming from. Just know that let me take you back from here. Remember, this is a uniform distribution, a uniform distribution that I told you earlier. So this means that it has what we call probability density function of the form f of x. So f of x is equals to 1 over k. So that is for the uniform distribution. Don't confuse your uniform distribution with continuous distribution. So we can get our value of k. So k is equals to our value of n minus 1. So in this case, it will be so k is equal to 79 minus 20 minus 1. So here definitely our value of k qualifies to be 60. So k is equals to 60. So you find that here the value of k was 60. So here it means that for us to be able to get the variance of x, so here we're going to write, so the var of x, is equals to, into brackets of your 60, raise it to power 2 minus 1, then you divide it by 12. Yeah. So this is like having 3600 minus 1, that is 335,999, if I'm not wrong. Then you divide by 12. So 60 squared minus 1 from my calculator, then I divide it by 12. So I'm getting something closer to 299.91666.7. So definitely that is our variance. So then you can get our SD. So this is the standard deviation. So this is the backslash of our SQRT. Then you close the bracket, and then you just get the square root of 9166667. I can just put it up there. So from my calculator, the square root is coming to around, so enter, backslash, so our standard deviation is equals to 17.3181, but you can give the examiner the standard deviation to 2 decimal place, so that is we'll be having 17.32. Yeah, so that is it. Yeah.